Hey Research Stat 1 class, this is Stephanie and I am coming at you with a video about reliability and validity. So reliability and validity were discussed in our first unit in chapter 3, and they are ideas that we're going to continue to see for the rest of the semester. So in chapter 3 and for that first exam, all you kind of had to do is read the book and kind of memorize, right? It was kind of regurgitation stuff. But as we move forward in the class, what you're going to see is that we're going to start really applying those concepts. And so while memorizing the definitions of each of the reliabilities and validities is important, and it's certainly the foundation, right? Because you can't understand a concept if you don't understand the definition of it. We have to start moving beyond just that simple definition and really considering what these things really mean. So reliability, of course, what you typically hear about reliability is that it's this idea of consistency in the measure. And if you don't have reliability, then you cannot possibly have validity. So it is impossible to have a measure that is valid but not reliable. And here's why. So think about this. Personality is a construct that we use in psychology quite a bit. And one of the reasons that personality is important and useful is that there's this idea of consistency in personality, right? So who you are today is pretty much who you should be tomorrow and the next day and the next day, right? And if you're not consistent, then we know that some things may be going on. If we just met you yesterday, we might not know which of those two people you really are. But if I've known you for 20 years, and today you're acting weird, I know something's off, something's wrong, right? Something's going on because there's a lack of consistency there. Well, when we think about psychological measures, we can think about consistency as well. So if I am measuring your personality, let's say I'm measuring your neuroticism score, that score should be relatively consistent today, as it is tomorrow and the next day and the next day and even years from now. Those scores may not be exactly the same every single day, even if I measure them with the same test, but they should be incredibly similar. And so that idea that every time I use a test of neuroticism on you, you should get a pretty similar score is actually really important in our science. And that's the idea of reliability. So reliability is going to assess kind of the extent to which measures consistently result in similar findings. And we want that to be high for the most part. Now, if we're conducting an experiment and we're applying a treatment, let's say for something like depression, well, I would expect scores to change over time because I'm intervening, right? I'm giving you a treatment. But if I'm just measuring something like personality that's supposed to remain stable, it should remain stable. That means that I should get relatively consistent results. One of the things that's going to help us understand things like reliability and validity is to go back and remember what we discussed when we talked about things like operational definitions and constructs, right? So if I have a construct and I say, I'm measuring neuroticism, I have to be able to really operationally define what that construct, neuroticism, means for my study. And so here's that idea again of operational definitions coming back and the importance of them, right? How important they are to our field. So the book talks about a number of different types of reliability, and one of the things that I want you to notice, I won't go through them all because you've already seen them, but one of the things I want you to notice is this: reliability, for the most part, can be mathematically determined. And if you noticed, the most common thing that we're going to do is correlate things, right? So we get Cronbach's alphas, or we do simple Pearson correlations, and we look to see how consistent were those measures. So we expect those correlations to be really high. The maximum value you can get for a correlation is a 1, whether it's a positive 1 or a negative 1. The maximum value you can get is a 1. So we want to be really close to a 1. The closer we are to 0, the more problematic the consistency is, the more the closer we are to 1, the better. I want to make sure I said that right. The closer we are to 0, the worse the consistency or reliability is. The closer we are to 1, the better the reliability is. And that's true for all of those, right? Iterator reliability and test retest and split half and all those reliabilities. But what's unique about reliability is that it can be mathematically established. So we can tell pretty quickly with a measure if it's consistent or not. We might test you today and then in a week and then in 2 weeks. For some of these others, like split half reliability, we can actually give you a single test and test split half reliability right away. But in general, we can understand how consistent a measure is really quickly. Okay. So reliability comes first. If a measure is not reliable, we don't even have to worry about if it's valid. We know it's not, because the measure itself is not giving us consistent results. But if it is giving us consistent results, then we get to start to worry about validity. So validity is called accuracy. So one of the things I do when I teach this face-to-face is I do this little cheerleading thing, and I'm like, I say reliability, you say, and then you say consistency, and I say validity, and you say, and then you guys say accuracy, right? And it's just a way to kind of get that into your head, because they're really easy to confuse. But remember, if you have consistent results, you have reliability, then you get to worry about, am I really accurately measuring what I think I'm measuring? And one of the things that I want you to notice about the types of validity is that they are not, for the most part, there are a couple that you can use some statistics to establish. But for the most part, we're not using statistics when we talk about validity. Instead, validity is kind of this conceptual thing. In fact, the most important type of validity, right, is construct validity. And construct validity is built over time using the other types of validities. So it's not even something that you can establish quickly. It's something that takes potentially years to truly establish. And even once construct validity is established, because we are a ever-evolving science, as we learn more, we may start to question some construct validity. Even if it's been something that we kind of bought into for many years, as we learn more and maybe find better ways, different ways to test things, we may find that sometimes that construct validity is no longer really accurate or valid. It's a really interesting issue. So the book talks about several different types of validity. If you followed through with the book and the PowerPoint notes that I gave you, you'll see that I have some additional types of validity and some additional explanations for each of those types of validity. But I want to touch on just a couple of these. The first is face validity that I want to talk about, because I think a lot of times when I was a student, it was not clear to me that face validity is to some extent, I don't want to call it useless, but it's a first step. And it is kind of the most basic type of validity. And ultimately, we don't really want to count on face validity. So face validity is the idea that on the surface, the measure appears to measure what it's supposed to be measuring. But again, that's just at a first glance. So face validity is used a lot when we're first constructing scales. So the item looks like, so I know that people who are depressed should be sad. So I ask a question about sadness. I know that people who are depressed sometimes have sleep disturbances. So I ask a question about that. So on the face of it, it looks like it should be measuring what it's supposed to measure, but it's very superficial, and it's not really very useful at all for establishing validity. So we need to think about these other types of validity then. Remember, the ultimate pinnacle here that we're trying to achieve is the construct validity. And these other types of validity then kind of support that larger construct validity. So we have things like content validity. So the idea in content validity is that the scale items are measuring what they're supposed to measure. So ideally, if you have a large, broad construct, you are assessing all aspects of that construct. And content validity kind of speaks to that to some extent. because those scale items then become important, the wording of the items is also very important. You don't want to use words that your population is unlikely to know, because you're not going to be there to translate it for them. So you want to make sure that your items are written using proper English in our culture, right? You want to make sure that you're using proper grammar. You want to make sure that you're using words that people understand. These are all important contributors when we think about that. Another type of validity that's really important is what we call criterion validity. When I was you guys, it was called criterion related validity, and so I sometimes still call it that. So if I stick a related in there, I'm going to pre-apologize for that. But criterion validity is the idea that your measure is highly correlated, that it's similar in some way to some other measure of the same construct. So some people talk about, this scale should be similar to a similar scale. And that could be a criterion if you're testing it against some gold standard, some criterion. But it doesn't necessarily have to be another scale. And I want to make sure that you understand that. When we talk about criterion related validity, it's just the idea that your measure matches up in some way to some existing measure. And so that could be a set of behaviors that you're looking at. It could be the gold standard of a test, but it could also be, I think about this a lot with like abnormal scale development. When we're testing for abnormal psychology, one of the things we might do is have a clinical assessment from a psychologist, and we might compare our pen and paper measure to that clinical assessment to see how similar those are. So there we go with the related, right? Criterion validity can take on a lot of different aspects. It can look a lot of different ways. In that, I would say it's very, in a lot of ways, it's kind of driven by the type of psychology you're doing. If you're doing abnormal psych, you're more likely to get that criterion from existing psychological assessments. From a clinical standpoint, as opposed to like a pen and paper measure. For me in personality, I do a lot more comparison with like existing pen and paper measures. That's more common. And then you can read about convergent validity and discriminant validity, also called sometimes divergent. So convergent, divergent. But this is the idea that if I have a scale that's similar to, that's measuring a similar construct, then I should get really high correlations. If I'm testing my measure against something that's very different, right, divergent, then I should get very low correlations between the two. And this is actually kind of important. Both of those types of validity are important. So make sure you read about those. So the next thing I have in the PowerPoint notes, and I know that not all of you have looked at the PowerPoint notes from from the first unit, because I can see that only about 40 of you open them up. I'm sorry, I said 40. Only 14 of you opened it up. So there's quite a few of you that didn't look at the PowerPoint notes, but they are important. You've got to start looking at those things. I have this little schematic. It's actually from Carver and Shire's Perspectives on Personality book, and I really love this this way to think about validity and reliability in a like in a visual way. It's, not everyone's a verbal learner. So some people really have struggles with this, and then they see this and it's like, boom, they get it. So, there are different ways to think about reliability and validity, but if you look at this, what they have represented for you is a scale that's not reliable. So if you think about this as like shooting target practice, right? The shots are kind of all over the place. They're not consistent. And because they're not consistent, they cannot focus in on the bullseye, right? And so you get this problem where it's impossible for it to be valid, right? And the next one they show you is something that's reliable but not valid. So it's consistent. The shots are all happening around the same place, but that place is not near the bullseye, so it's not accurate. So it's consistent but not accurate. And then finally, reliable and valid. What I want you to pay attention to, what I want you to notice, is that there's no schematic here of something that is valid but not reliable. And again, it's because validity has to be established first. It is impossible to have a scale, right? Think about this. Would it be possible for you to have a scale here that was not consistent but hitting the bullseye? No, right? That's impossible, because if you're not consistent, then you cannot possibly be hitting the bullseye. So you cannot have a scale that is valid but not reliable. It's literally impossible. Okay. All right. So the next thing I have for you in the PowerPoint notes is a series of things that I want you to consider that have to do with reliability and validity in the real world when we're trying to have a research program going. So you have to think about, what are the implications, for example, if you use a scale that is not known to be reliable or not known to be valid? And certainly if you are creating a scale, you can establish some of the reliabilities very early on, and you would probably write a paper about that and publish those, make those well known. The validity is more questionable, right? That's built up over time. And so it is the case that we may use on occasion, right, measures that are not, they don't have beautifully established validity. And that happens, especially with young scales. So some researchers are really reluctant to use newer scales because they don't have the established validity. But at the same time, as we learn more about a construct, we should be changing our scales, right? We should be updating our scales. We should be using the knowledge that we have to create better measures. And so getting stuck in a rut with some of these what are considered gold standard measures is a real issue in our science. We have some people who are still using depression scales that were created in the 60s. And they get revamped every once in a while. But if you look at those scales and compare them to like what we know now, there's a lot of additional revision that needs to be done. And it's lacking and it lags behind. And again, some of that is because of researchers concerned with validity. But at the same time, as you know more about a construct, if you don't revise the scales, then you are not using a valid scale, right? And so it's kind of that catch-22. And so I have a couple of things that I want you to think about, like how often should a measure be revised? How often should it be standardized, and how often should that happen? Think about taking a scale from one culture into a new culture, right? What are the implications of that in terms of reliability, in terms of validity? And so you start to have questions about things like cross-cultural validity, things like that, that get really interesting. So look through the end of that PowerPoint. These are kind of questions that I want you to consider. And when we have our next Zoom meeting, if you guys if you guys want to, we can start to talk about some of those ideas and flesh them out a little bit more. All right. I hope you have a wonderful day. And if you have any questions, as always, shoot me off an email. Bye-bye.